okay, kid. Adrenaline rush. All right, so no. Finish section 4.4. That's our goal. Hopefully we do it. But guys, it's just a brutal section. Not brutal. It's just big. Maybe I should have split it into 2 pieces, but whatever. We're working on it. We're getting there. Forever quiz number 2. I have 30 to 41. I don't exactly remember how many forevers there are. We'll see today. We're starting review on Monday. We're finishing review on Tuesday, and then the test is on Wednesday. I forgot since I shifted everything one day. The test is on Wednesday. It's on the backboard, etc. Homework, last homework due on Monday. Brandon, go.
What's empanadas?
I have no idea.
It depends what country.
Chair by chair. Ooh,
Oh,
what?
Oh, I like
Nice. Whoever's doing it.
Oh,
team.
what are the I don't know.
Okay, that would be easier though. That was so fun. What are those ones? The ones with S's that have like the fun stuff on top? Okay. I thought there were those, and that always takes forever to serve. Okay. Empanadas. Okay, come back. Which one? Empanadas or something? It depends on who makes it, but it can be really easy. Okay, hold on. Let's go. Go team. Okay, kiddos, forever number 39, one more time really quickly. Shh, focus. We're going to go over this idea much more because it shows up in AP questions and it's going to be, most of you will think to use this formula. If you have memorized your forevers at all, you think average, you see average, and you say, hey, average, that's the F of B minus F of A all over B minus A. But, wait, you need to attach in your brain, that's the average rate of somebody. Not just average, it's the average rate of somebody. So this thing that we wrote down yesterday really quickly is, the average rate of position is the average velocity. Okay? Average velocity. But, who am I being given in this first part, letter A? What's given information? X of t. So I've been given X of t. There he is. I've been given X of t, and I want velocity. I've been given X, and I need velocity. I'm not going to take the derivative, though, because they're not saying instantaneous, but I still need to get, this is measured, for instance, in maybe like miles. I still need to get miles per hour somehow. So I have to do physics people, displacement over time. I have to do old school people, rate equals distance over time, but average rate. You still have to get miles per hour, so you have to do a change in position over a change in time, okay? However, what's different in letter B, because there is a totally different formula. You're given who? Yeah, you're given velocity instead. And you want the average velocity. Wait, this is the exact same thing? Yes. So how can you be finding the exact same thing but with a totally different formula? Because when it says average velocity and you're already being given velocity, then it's the average value of who you already have. I don't want to go another rate. I already have, for instance, miles per hour. Now, if we were, for instance, trying to find average test scores for the last test, which was last semester, it was the final struggle. Let's go with the last normal test. Anyway, we're trying to find the average test score. Come on, guys, this is old school. What would you do? Add up all the test scores and divide by
the number of
how many? So why isn't this formula as easy as add up all the different velocities? Wait. Isn't velocity continuously changing based on time?
Yeah.
So what's the velocity at 1? Negative 1. So going left at 1 unit per unit of displacement, just say miles per hour. How's the fastest going at 2? Oh wait, so can't we just plug in 0, plug in 1, plug in 2, 3, 4, and 5, and divide by 5? No. How fast is it going at 1.1? 1.2, 1.3, 1.4. Oh no, how about 1.11? How about 1.12? How about 1.13? Uh-oh. Wait. How many different velocities are there?
Infinitely
many, because the velocity is continuously changing. So how, wait. So how do we add together all of the infinitely many velocity values that are happening between 0 and 5? The integral takes that infinite sum for me with one quick f of b minus f of a subtraction, And then I just need to multiply by 1 over 5 minus 0 because that is basically,
Dividing by 5.
But aren't
yeah.
you doing the same exact thing?
No.
Like, well, because once you take
Never.
the integral.
Because if you just do 0, 1, 2, 3, 4, and 5, actually it's in
lose
between
precision.
0, 1, 2, anyway. 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. If you just do those few, it's still technically,
You lose precision.
you lose precision because you're not considering all the ones in between. The integral considers all the ones in between. Now this little 1 over b minus a is like the average that you're used to because it's dividing by the total change in the interval, but it's not the total number of quantities, it's the total change in between 0 and 5.
But if you did the f of b minus f of a, that's the same thing as s of b minus s of a.
And so Katrina is actually saying what I'm about to tell you. These find the average the exact same way. What? No, they don't. They're two totally different formulas. Bridget and Violet, shush. But these two formulas find, listen, these two formulas find the average velocity the exact same way. Well, maybe I shouldn't say that. Find the exact same average velocity because, kiddos, if you anti-derive velocity, f of b minus f of a, don't you get position of b minus position of a?
Yeah.
Isn't that the antiderivative of velocity?
Yeah, but you don't put the negative 1.
It'll end up solving the exact same way because the negative ones will be in both and it'll subtract just like the plus c's always do. Does that make sense, Brandon?
Oh, yeah.
Okay. So why on earth do we have this formula if they solve the exact same way? Kiddos, because sometimes they're not going to give you the position like I did in this problem. They're going to give you the velocity and maybe you can't integrate him by hand and you're just going to be using your calculator.
Oh.
Does that make sense? Or they give you a table or something with velocity values so you can't even use the position function anyway. Okay, that's all we're going to talk about average value. You guys have your motion packet? Uh-oh, where's the motion packet? That's okay. Motion packet. I don't know where he went. Motion packet. Actually, you know what? I bet he's at the end of this thingamabob. Nope, he's not. Oh, here he is. Got him. Okay, motion packet. We are on worksheet number 4. Violet and Bridget, shush! Goodness gracious.
Oh.
Okay, help me out. Fill it in. Speed is the absolute value of who? You gotta go fast on this one. It's not hard. Bridget, where's your motion packet? Okay, come on, kids. It's been 5 minutes.
Velocity.
Speed is the absolute value of everybody one more time.
Velocity.
Velocity, right? Because I said to get out motion packet. If the velocity and acceleration have the same sign, both positive or both negative, then speed is what? Increasing. Thanks, kid. If the velocity and acceleration are what in sign, then the speed is decreasing. Yes, if speed is decreasing, then they must be opposite in sign or different in sign. If they're the same sign, speed is increasing. All review, right?
Yes.
Now it gets not reviewish. There are 3 ways to use an integral in this. Well, I guess number 4 is review. There are 3 ways to use an integral in the study of motion that are easily confused. Watch out. What kind of integral is number 4?
It doesn't have numbers on it.
It doesn't have bounds, therefore it's called a non-bounded. No. Indefinite. Good. An indefinite integral, it will give you an expression for, wait a minute, we have this in a forever card. If we integrate velocity, an indefinite integral, what do we get? An equation or a function for?
Something important position.
Position. Good.
Did I get? Oh man.
Does that make sense? Integrate velocity, go back to position. True? Don't forget that you will have, wait, if it's an antiderivative indefinite integral, what do you always have to put down?
Plus C.
Plus C. If you don't, you're going to kill a poor little red panda. The sign is back at my desk, but I still need to write it.
A red panda?
Yeah, it's cute.
What's the worst one? What's the panda that's red?
The value of which can be, exactly, of which can be determined if you know a position value at a particular time. Number 5. What kind of integral is that one with bounds?
Definite.
Go team. So the answer will be Wait, all definite integrals, are those equation answers or
Constant.
numbers, right?
Constant.
It'll be a number, or if you want to put instead, it'll be a constant. That's fine.
Oh yeah.
The number represents the change in, wait a minute, Katrina, you just figured this out.
No way.
No, integral of velocity goes back to position. Good, it's going to be a change in position over the time interval. By the fundamental theorem of calculus, the integral will yield, I want you to circle, x of t2 minus x of t1, because there'll be antiderivative of b minus antiderivative of a, and we just said the antiderivative of velocity is position. True?
Yeah.
This is also known as, displacement. That sounds important in physics. The answer can be either positive or, you guys can fill it in, negative. Depending upon if the particle lands to the right or left. Wait a minute, so if it lands to the right, what kind of displacement is that? Positive, like a positive velocity is going, it means you're headed to the right. If you land to the right, or if you stop to the right of where you started, the original starting position, which we would say is x and that. You're going to have a positive displacement. If you land to the left, negative displacement. If it's an up-down model, if you land up, which is weird. If you end up, anyway, it'll be a positive displacement. If you end up down, it'll be a negative displacement. Number 6.
Be safe.
I found. What kind of integral is it? Definite. And so the answer will be, once again, a number. How many of you guys cheated and went ahead and saw what that was?
No,
Never mind.
Too good.
The number represents the, wait a minute. No. Displacement tells you if you land to the right or to the left, the positive or the negative counts.
Value. The speed.
This is absolute value, so it's the integral of speed, so you're just accumulating distance. Total distance traveled.
Total.
Distance. What do I mean? In number 5, struggle. How can I do this? Well, first of all, let's fill in the last blank. The answer should always be if it's absolute value. Okay, now hold on. I need eyes on me.
Cool.
Eyes on me. Eyes on me. I'm not in front of the room. Okay, ready? If this is my initial position, and I am the stylus, if I move to the right, what kind of displacement is that? Positive. And then I go back to the left, and then I come right back here.
The displacement would be 0.
What's my displacement?
0.
Why? I end. I'm
I'm
not displaced from the original position. I'm at the exact same place. Even though I went here and then here and then here, the displacement is 0. So if you add that positive and you subtract this number and then you add that number, you're going to get 0, right? Okay. So positive displacement, negative displacement, positive displacement, add them all up and it's going to be 0. But question, what would your odometer say? Wait, guys, help us out. Or girls that know stuff about cars. What's the odometer?
It's the mileage.
It's like the trip meter.
Yeah. And if you go in reverse, it goes down.
No.
In old cars, right? In old cars, not new cars.
It didn't work.
So question.
I know it didn't.
Question. Did you travel distances to get to this place?
No.
Oh, no, did you travel though? Did you see me travel? I traveled. My odometer counted up. There's more mileage on the car than when you began. Barely any, probably, right? Those were like inches. 100 miles. Okay, whatever. So, the odometer changed. That's total distance. How much did it change? This one, absolute value of this one, plus that one. Does that make sense? So the positive stays positive, the negative turns positive, and the positive stays the same. Add them all up, and you have a total distance that the odometer would have ticked off. Does that make sense?
Yeah.
Ticked off, that sounds wrong. That would have counted off, would have, whatever. Okay. Anyway.
What was the last one?
Positive.
You love it? I do.
You love it, because you can just talk all the time.
No, you yell at me more than normal.
That's true, I see you better. But then you start participating. Ella, go ahead. Get the forever card first, then you can. Forever number 39. Oh, it is?
Yes.
Is it really?
Yeah.
Really? I thought 38 was the average value.
What?
Wait, no, I have 38.
Yeah.
That's 37. So where was the other one? 37,
I have
38.
Average
Stated about my name.
is the average value.
I have 38
the
and
one
8.
that was on the page you started to begin with. No, it's not.
37. Shh.
Where's the
36. Wait, I'm good, right? 36.
No.
Not the 1 over B. Yeah, the 1 over B minus A.
The average value is 39.
first value? So it's gonna be like the that one?
Oh, so we went backwards.
Yeah.
Got it.
You park in the parking lot there?
What did I do?
Okay, forever number 40. Thank you. Forever number 40. Struggle. Where did Bridget just go?
She's getting Advil.
Want to get me some? Just kidding. Actually, no. I didn't take mine this morning, but I have them in the back of my purse. Yeah, do you mind? Thanks, kid.
No.
Bridget inspired me. All right, so total distance traveled. It's going to be the integral from T1 to T2 of B of TD. I know it's so cute.
That's the red can.
All right, Star, hold up the red panda. It's okay, hold it up fast.
This video for this class.
Okay. It's so cute. Isn't he cute? He's like, oh my God, he's red.
Oh,
you have to use the video.
Oh my word, you guys. We need to pause this thing. Okay. Total distance traveled from T1 to T2 of the absolute value is total distance traveled. Add them all up. I know Ryan Murphy made his own makeshift until I made a good one. Displacement. Hold on. Why did I leave it blank? There are 2 ways of talking about it. Shh. 2 ways of talking about it. Yes, it could be the definite integral from T1 to T2 of V of T dt, but someone help me out with FTC. What is another way of writing it? We just circled it a second ago.
Vx sub
Yes.
T.
There's
No, wasn't it
X is
X
equal
B
to
minus
minus
X?
It might get back.
X of T2.
You guys see it? So, question. If you have position, which formula are you using for displacement? That one. If you have velocity, which formula are you using for displacement? That one. Got it? Good.
Wait.
It's okay. 2 more seconds. Put it on the video. Math is better than drugs.
I love drugs. Math with drugs.
Only for Sherlock Holmes.
Call me Sherlock. You can be my Watson. Oh God.
She makes herself laugh and I love it. That's the best thing.
I know.
Aaron, no telling secrets. Secrets don't leave friends. Okay, so.
Exactly.
You guys got it? No, come on. No. Okay, it's on the motion packet. Just copy it down. Need total distance and 2 formulas for displacement. Cool. Let's keep going. Oh no! Oh my God, there's so much. I know, I told you, it's a big day. Just keep going. Just keep swinging.
How many lines after displacement?
Another one?
If you guys are missing the last forever card, it was
Star.
displacement, integral from T1 to T2 of V of T dt. If you're missing total distance traveled. Oh, I said that backwards, didn't I? If you're missing forever card number 40, it was total, total distance traveled, integral from T1 to T2 of the absolute value of V of T dt. If you're missing displacement, it was called displacement. The first formula was x of T2 minus x of T1. And the second formula was the integral from T1 to T2 of V of T dt. Now, some of you are like, I never took physics, so this stuff is hard. True, but if you ever take physics for any science major, any medical major, which is also kind of sciencey, for any sort of physical therapy major, for any sort of maybe computer science. I think last I heard somebody was saying their brother had to take it recently at one of the UCs for computer science. Anything mathematical, anything engineering, anything business, maybe not for business. You're going to need to take physics, and guess what? Calculus is giving you an introduction. Nice. Physics can give you an introduction to the physics stuff in calculus. Physics stuff in calculus can give you an introduction to physics. Oh, the variables are weird because they're not constants, and that's why we need this forever card. The variables for the first one, FTC Part 2, or I think our book calls it the second fundamental theorem of calculus, but they kind of are tied together. Do you see the bounds a little bit better? A to x and A to u. A to x and A to u. Now hold on, wait a minute. Come on, you guys should pre-count. Why does it kind of make sense that the derivative of an integral would just be f of x?
Because
The integral is the antiderivative, and then if you derive the antiderivative, don't they kind of cancel?
yeah,
Does that make sense?
yeah.
Because there may be inverses of each of them. Ah. So where does it get kind of hard? In the second one.
If you
There are two different pieces in some senses of this theorem, and they both are very important. And I think technically, historically, maybe this one was found first and then the other one. Some books actually call this FTC Part 1, and the one that we learned first, FTC Part 2. But the reason why we learn it in this order is because f of b, antiderivative of b minus antiderivative of a, is the general form. It's kind of like talking about MVP before goals. And this one is a specific application. Now, how does this one go to work? It's actually not hard. It's actually not hard. And the reason why we need to memorize this, because technically some of you are like, whatever, why don't I just find this and then why don't I just take the derivative? Well, if you can just know what the answer is going to be, wouldn't that save you a lot of work in between?
Yeah.
Okay, so that's the idea of what's going on. Okay, let's go ahead and look at the first example down below. So, given that capital F prime equals little f, long story short, given that capital F is the antiderivative of little f, let me show you how these work, first of all. Okay? PEMDAS tells us do the inside first, and the inside is technically the entire integral. So let's keep the derivative. I'm just showing you how it works. You can tell from up above what the answer should be, but how does it work? Well, antiderivative of b minus antiderivative of a. And guys, yes, x is a variable, but we can still do fundamental theorem of calculus with it. If you were to if you were to solve this definite integral, you would have antiderivative of x minus antiderivative of a. But what do we still have chilling on the outside that we need to do? A derivative. So then we would go ahead and say, okay, cool. Then that would be capital F prime of x minus capital F prime of a, right? No. What's a prime? X prime is 1, but what's a prime? If we were to do chain rule. F prime of x times 1, because x prime is 1. What would this one be? F prime of a times 0. Wait, what? What's f of a? Isn't he a constant? And what's the derivative of any constant? 0. So what do I end up with? Capital F prime of x, who is who? Dun, 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 dun. Proven. Dun, dun. Well, I should say illustrated, not proven. So what on earth is going on with the second piece? What on earth is going on with the u prime? Which, just a heads up, that's another way a poor little red panda is going to be able to die. If you forget the u prime with derivatives, or if you forget the plus c with integrals. Don't forget the little things, because they're quite important. So how does this bottom one work? And why on earth is there a u prime? Well, let me show you. Okay? Let's do the same thing. You guys help me out. I'm going to rewrite d dx, but if we PEMDAS start in the parentheses or the brackets, whatever, the grouping symbols, what would we have? What would we have? Oh, come on. You got this. F of, capital F of, x squared minus. Does that make sense? Should we track it? Fundamental theorem of calculus. Antiderivative of b minus antiderivative of a. Let's make sure we're not too distracted by what's on our phones that we're looking at instead of calculus. Not pointing out anyone and not even looking at them right now. Let's keep going. So antiderivative of x squared minus antiderivative of a. Cool. But what do we still have on the outside? The derivative. So let's take that derivative. How do we take the derivative of the first piece? Well, okay, yes, you're right, it's 2x. Let's just write it the way that we would find it, which is derivative of the Matryoshka dolls. Come on, give us derivative of the outside, keeping the inside the same, times derivative of the inside. Some of you were trying to shortcut it, and I realize it, but I want people to be able to compare with the formula up above. So, capital F prime of x squared, chain rule. Derivative of the outside keep the inside times derivative of the inside minus, what did we learn from up above? That this guy is a constant, which he is. Yeah, the derivative is just going to be 0, right? Hold on. Who is this guy again, according to what's up here? Yeah, he's just little f of x, right? So we're going to get f of, oh, not f of x though, f of who?
X squared.
Times 2x. Who is this compared to the original? Because you don't want to have to do this work every time. I'm just trying to show you how the formula works. Isn't it just f of u times u prime? Isn't it the same thing? Who's the u? And where did the u come from? You see it? F of u times u prime. So, we could, theoretically, do all the work every single time, but that doesn't sound fun, yeah? Let's just skip. Let's skip to the end. But we have to memorize the difference. Now, hold on, wait a minute, hold on. Technically, do you really need to memorize both A and B? Not really. Which one is the more general one, A or B? No.
B.
Why?
Because it has.
Couldn't we do, or couldn't we see this guy as a u? Then wouldn't it be f of u times, what would u prime be if u is x? Oh, doesn't that work?
Yeah.
So what's the most important part of this card? If you're going to just memorize one, if only one's going to stick in your brain, you better make sure it's B and not A. Are we tracking?
Yep.
Because guess what most calculus kids get stuck in their brain? And guess what they totally forget about when the AP tests them? Hey, you don't kill those big poor little red handeds. Alright, cool kids. We have one more idea. You guys have been doing a great job. Remember I said there was a lot in today. We have one more idea we got to cover unless we have some examples. Ooh, we do. Let's do a quick example. Wait, hold on. According to the forever card, before we do the example, who can A be? Who can A equal? A number. What number? I don't care. Can it be a negative number? Yeah. Can it be a positive number? Yeah. Can it be a 0? Yeah. Can it be something with a pi? Mm-hmm. How about with an e? Mm-hmm. How about something with a square root? Mm-hmm. A can be anybody. Cool? And the answers are still the same. Cookies for breakfast? Go. Person with your phone that is still distracted, put it away. I really don't want to have to take it. Okay, we have our function. Capital F of x equals, why capital? Oh, antiderivative, kind of makes sense. The integral from pi over 4 to x of cosine of 2 t dt. Alan, do you have a question? Okay, that's awesome. I'm dreaming. The integral from pi over 4 to x of cosine of 2 t dt. Now, be careful. Things look a little funny. Were there t's in our forever card? I changed it last year, but I forgot this year. I am so sorry, kiddos. Go back. Go back, go back. The AP is never going to put x's in both the bounds and the integral. Because they're like, wait a minute. They're standing for two different things. I am so sorry. Erase the x's in the integral. They're never going to put x's both in the integral and in the bounds, because x can only represent one thing at a time, okay? Instead, they're going to do what you guys can see in that example. I need a thinner pen. They're going to use like t's instead, maybe another variable. But x is only going to be in one place. Does that kind of make sense? Okay, sorry, I apologize for that. I thought I fixed it.
What about the?
No, it still equals f of x, because the x, remember, when we go to take the antiderivative, doesn't the x get plugged in just the same way as the u gets plugged in? Does that make sense? Okay, so that's what's going on. The x is still, that's why I need to show you that, because you guys might get confused. So over here, when we have the integral from pi over 4 to x of cosine 2t dt, and technically I should probably put little parentheses so that you guys know that that's allowed to be included. How would we find capital F prime of x? Well, if we take the derivative of one side, what are we going to do? Take the derivative of the others. Take the derivative of the left side. Morning, kid. We're going to take the derivative of the right side. Okay? The derivative of the left side, we say, okay, no big deal. That's just capital F prime of x, right? How do we take the derivative of the right side? FTC. Part 1, part 2, depending on what calculus book you're in, doesn't matter. FTC tells us to, Katrina, quick question. It's ddx. How come? Because they're going to be x's when you antidirect. Does that make sense? Yeah, it looks weird. I know, that's why I have to get you guys on the same page as me. There are t's in the integral, but x is going to come in if we were to actually solve this the long way. Okay? So according to my theorem, it says the derivative of an integral from any a to any u, in this case it's an x, but either way, any a to any u is f of u, which means take the integrand and plug in who? X. Times x prime is 1. No, wait, times u prime is 2. No. Who's u? Remember? Who's u? X. Right? This is where it gets confusing. Some of you would have put 2, and I understand it happens every year. But we gotta realize we're plugging the x in, and then we're saying times x prime. So if it helps, think about it this way. Set this equal to u. Write your little f of u times u prime. And then we can, if it helps, if your brain got confused on that, you might need to show this just to help yourself out. So then you plug in cosine of 2 who? X times x prime, because x is the u. Does that make sense? And that is why our final answer, cosine of 2x times 1, is cosine of 2x. Dun, 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 dun. Now, technically letter B says check it by solving it the long way. We're not going to do that because technically we don't know how to integrate an expression with a u yet. What? Ooh. Yeah, that's not just cosine of t, that's cosine of 2t. We don't know what to do with him quite yet. So we're not going to check letter B. Alright, cool kids, thanks for doing that example with me. We're going to actually go ahead and skip ahead to the last big concept. Remember I said there were a lot. MVT for integration, or for integrals. The good news is it's not really different than MVT for derivatives, but we're not having an f prime of c in there. We're having an integral instead. So it's MVT with integrals, for integration, however you want to think about it. And this is why our count got a little bit off. I'm sorry, I forgot that I made average value for every part. Okay, this is our final forever part of chapter 4. MVT with integrals, with integration, for integration, however you want to think of it. If f is continuous on the closed interval a to b, then there exists a number c in, wait, this sounds awful similar, right? What's missing? Differentiable. How come? Well, if it's coming out of an integral, it must have been differentiable. The antiderivative must have been differentiable to have an integrand that exists. So we just have to say if f is continuous. Then there exists a number c within a to b. Interesting, within the closed interval, not the open struggle. Something a little bit different. Such that this is one way of showing it, there is another way of showing it. And let me see if the other way of showing it makes a little more sense to you. last thing I added might not make a lot of sense to you unless you remember. The conclusion of MVT. There exists a C within A to B such that f prime of C equals f of B minus f of A all over B minus A. Wasn't that average rate of f? Or in this case, average rate of capital F? That's average rate of. MVT for integration says we have the function for whom we want the average, so we can say little f of c is the same thing as a derivative. 1 over b minus a times the integral from a to b of f of x dx is the average. It really says the same thing. It really says the same thing. Because to be specific, if we were to solve this, the reason why I wrote that last thing is because we could rewrite this as just this little bottom piece. As capital F prime of C equals capital F of B minus capital F of A all over B minus A. Now I'm going to put that in parentheses. You don't have to write that in your forever card. I wouldn't make you write that for like a forever quiz. But if you notice, guys, this is MVT, but MVT for an antiderivative. You're not being given capital F, you're being given little f. So it's like MVT, but kind of backwards in the sense that we're not working with capital F, we're working with little f. Hopefully some of you guys can see how MVT applies. We're just going to go ahead and end with this final example. Find all values of x star. I don't remember if our book actually says x star, so there's a new book issue. Let's just go ahead and say find all values of c. Let's just keep it normal. Find all values of c. X star is just another way of saying c. It's something new, something different. And the stated interval that satisfy MVT. Satisfy? Oh yeah, because it could be plural. Satisfy MVT for integrals. How do we do it? We say, using the theorem, there's a place where f of c is going to equal 1 over b minus a, the integral a to b of, wait a minute, who is f of x dx? Yeah, steal the f of x from above. Okay, so wait a minute, who can I say is f of c? This is where you guys got confused last semester. F of c, don't we plug it in, right? So how do we actually solve this puppy? Well, we say, hey, we need to take the antiderivative. Antiderivative, long story short, x to the 1/2 plus 1 x to the 3/2, 2/3. It's going to be 2/3 of 3 to the 3/2 minus 0 to the 3/2 after doing FTC. We're setting that equal to square root of c. And guys, at this point, all we got to do is what? Solve. All we gotta do is solve. C equals maybe 1, maybe 2. Kiddos, great job. I know it was a busy day. The video has all the information. All we didn't do was practice FTC part 2 a little more. And I'm going to go ahead and solve those examples as you guys leave. That way they're online. If you guys get confused with FTC part 2, you can ask. You can go online and check it out. Bye, kiddos.